Good morning, everyone. What we're going to do today is continue with sequences. So let's just do a quick recap. This is a sequence which is described by a formula. And you could be asked to find the first three terms, more likely the first five. Essentially, if you're given a formula, it's plug and chug. So you plug in 1 here and you get 1 squared plus 1 is 2. 2 over 2 gets you, the answer would be 1. If you plug in 2, you get 2 squared is 4. 4 plus 2 is 6. 6 over 3, the answer is 2. You plug in 3, you get 9. 9 plus 3 is 12. 12 over 4, and you get 3. A very interesting pattern. Isn't it? Interesting sequence. 1, 2, 3. Or you could get a sequence that looks something like this, a recurrence one. Try to find one. Yeah, how about AN is do lots of that guy plus 1, and A1 is 2. Now, if you're given the information in a recurrence relationship, do you notice that the formula AN isn't in terms of n, it's in terms of the previous term. So you get A1 for free. So if you want A2, it's 2 lots of A1 plus 1, 2 lots of 2, add 1, you get 5. If I do the next one, A3 then is 2 lots of the previous one, add 1. 2 lots of 5, that's the previous one, is equal to add 1, and you get 11. And this would be a sequence that would start with 2, then you'd get 5, then you would get 11, and off you go. Now, you can pretty much do these by hand. Since there's only going to be, what, 5 terms, I think, typically in homework, find the first 5 terms. It's not that onerous a job. So let's move on to something a little bit different with sequences then. How about, how do you tell if a sequence is increasing, decreasing, or not monotonic, which is a new word. A sequence is increasing if you start with a term and the next one's always bigger than or equal to the previous term. So a sequence like 1, 3, 5, 7 is definitely increasing. A decreasing one, pretty much the same idea, 4, 2, a half, a quarter, that would be a decreasing one. Not monotonic is really just says, do you have a sequence that isn't decreasing all the time or increasing all the time? It's kind of, you know, sometimes going up and then sometimes going down. So you might get a sequence that goes 1, 3, 2, 4, 5, 7, 9, and so on, right? So you see in this case, it goes up, then it goes down, then it goes up, and then it goes down, then it goes down and up. It doesn't need to alternate. It could go down for 3 terms and then go up once, right? And then down for 4 terms and up twice. It just isn't increasing or decreasing. So you could, that doesn't look right. I think the I should be before the A, but it's neither or neither, right? But back to the question is, how do you tell? Well, I'll tell you how you don't do it. You don't find the first 5 numbers and say, look, the first 5 numbers in the sequence are decreasing. Therefore, the sequence is decreasing forever. Because can you imagine a sequence that maybe the first 50 terms are decreasing and then the 51 and the 52 and the 53rd term starts increasing again, right? You could get a sequence that did that, right? It goes down and then it could change its mind, or vice versa. So we can't do it by just finding the first 5 and saying, okay, that's fine. If it works for the first 5, it must be decreasing. We have to do it more algebraically. So Suppose I was being asked to do this one. If I was being asked, is it increasing, decreasing, or not monotonic? Monotonic means it's increasing or decreasing, by the way. How would I go about it? Well, you do this. Step one is you find the real valued function that has the same formula. So would you agree that that and that are essentially the same? And then, in step two, you differentiate this function. So, yep, calc 1 is coming in, differentiation. Now, am I going to use the product rule, the quotient rule, the chain rule? What kind of rule am I going to use to differentiate this guy?
Quotient rule.
Great. And the top's going to be f, and the bottom's going to be g. So let's see. F dash j, take away a of g dashed, all over g squared. Differentiate the top, you get 4. Leave the bottom alone. Subtract, leave the top alone, and differentiate g. And you get that guy. And distribute 12x, take away 8, take away 12x, take away 3, all over that guy. And we get the derivative, which looks like that. And now we have to find what happens when x is greater than or equal to 1. What I mean that is the derivative positive when that happens all the time, right? For any value of x bigger than 1, is it positive derivative? If it is, it means it's increasing then. That's how you prove it. If it's negative all the time, doesn't that mean that it's decreasing? And if it is neither, right, sometimes it could be plus depending on the x value, sometimes it could be negative depending on a different x value, then it's not monotonic. Right, let's look at this guy. Would you agree that for any value of x on the bottom, isn't 3x minus 2 squared always going to be a positive thing? Right, because anything positive, anything squared is positive. Would you agree that negative 11 is a fixed number, and so it's always negative? So what would that combination generate? Well, wouldn't that combination generate a negative derivative? If the derivative of something is negative, is it increasing or decreasing?
Decreasing.
And that is how you find out. Now, what you get in the homework are 3 little circles. One of them is increasing, one of them is decreasing, and one of them is not monotonic. All you do is you fill in the decreasing dot and you are done. But can you see there's a fair amount of work to do that? Will you please not do the, I'll guess the first one it's wrong, I'll guess the second one it's wrong. Since I get 3 guesses, I know I'm going to get it. Because what's going to happen in your test when you get that question is that you won't have practiced the process, right? And you won't be able to get the points. Because you only get 1 shot in the test, and it's not a good idea to risk that, right? So that's how you tell if a function, if a series, let's get this right, if a sequence is increasing or decreasing. This particular one is decreasing. Now there's a new thing we're going to be asked to find, and it's called, is a sequence bounded? Right. I want you to visualize that this is n, and this is the value of the function. So we have 1, we have 2, that's A3, A4, A5, A6, right? And it's this guy, and then 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 it's this guy. And can you imagine that in the story I'm trying to do right now, that this particular sequence levels off, right? It has a limit. Now, when we talk about is a sequence bounded, what we are saying is, can you place values here and here so that the entire sequence is always going to be inside that range, that boundary of values? Now, in this particular example, we need to know one more thing. And the thing we need to know is the limit of the function. So to answer the question, is a sequence bounded or not, what we really need to answer is, does it have a limit? Right, so if the sequence has a limit, it's definitely going to at least be bounded on this side, right, on the right-hand side. And typically it'll be bounded on the left as well, so it'll be bounded. So here is our problem. I want to find the limit as n tends to infinity of this sequence. And we're going to use Calc 1. Can you remember that in Calc 1 there were different techniques for finding limits? There was brute force, where you just plugged n equals infinity and typically you'd get 0 or infinity, and that works. Wasn't there a guy called L'Hopital, where you differentiated the top and bottom, then you made n infinite? And there was a third technique where you divided the top and bottom by, say, n, and then you could do the brute force. Now, in this question here, what technique do you think I might use to find the limit of this?
By n.
Okay, so what I'm going to do is I'm going to do the divide the top and the bottom by n. So this becomes the limit as n tends to infinity of, well, if you divide that by n, you get 4, and if you divide that by n, you get this, and you get that. Now, if you make n infinite, basically, you get this fella. Take away this fella. Now, as weird as that looks, it's not actually that weird. What would 1 over infinity get you, essentially?
0, right?
0, right? So 4/3. So this guy here would be 4/3. Or if the sequence was a set of points going down the way, the 4/3 would be here. But would you agree it's got a boundary? If you have a limit, you have a boundary, right? You're never going to get more typically than that number, right? Or less than that number, but it is a boundary. And if you look at the first term, whatever that first term is, if I plug 1 into this term here, A1 is 4, 1, 3, take away 2, it's 5 over 1, it's 5. So that guy there is 5. So can you see in this case, this sequence is bounded. It's bounded because it has a limit of 4/3, and the first value is 5. So if you have a limit, you will be bounded. If I did this and the limit was infinity, right, then it would be unbounded. Right, the sequence would just basically keep getting bigger and bigger, or minus infinity, I guess it would get, more and more negative, but it wouldn't be bounded. So when you see a question, is a sequence bounded? Well, you think of that question as being, does this sequence have a limit? And if the answer is yes, it will be bounded. And if the answer is no, the limit of that sequence doesn't exist, it's infinite, or it just doesn't exist, then you know that you're looking at an unbounded sequence. Are we cool with that idea? Finding limits is basically how you answer the question, is a sequence bounded or not? Right, so let me see if I can find another guy. That's too easy. Oh, let's try this one. We have a sequence. Oh, going green today. And we want to find out, is this sequence increasing or decreasing? And secondly, is it bounded? Right. So there are two distinct questions. First one, is this increasing, decreasing, or not metonic? And the second one is it bounded? Right. The real valued version of this function is that guy. And I'm going to switch over to blue because I like blue. And its derivative then is 2. I need to differentiate 3 over x, but that's probably not a good way to write the expression if you want to differentiate it. Now, if I call it 3x to the power of -1, does that make it a little bit more obvious what its derivative is going to look like? So when I differentiate it, it's going to be multiplied by the power and reduce the power by 1, which now gives me 2 take away 3 over x squared. And now we ask ourselves, what's that derivative going to look like for values of x greater than or equal to 1? Let's make the number just a little bit bigger. Let's suppose I plugged in, yeah, say 2, just to be sure. Would you agree that 3 over x squared, especially if the number's 2, 3, or 22, isn't that quite small? At least it's smaller than 2. So won't the net effect be that this answer is positive? Now, there is one exception to that. Do you know when x equals 1, the answer might be a negative derivative? But it's okay for a function for just 1 or 2 numbers to go downhill as long as the rest of them for eternity are going uphill. So technically, we would still call that an increasing function, even although it's not for every single value. And that's why I had to change that to 2. So when you look at a question, theoretically, you should be saying x greater than or equal to 1. But because sometimes the first 2 or 3 terms kind of jump up and down a little bit, you might want to say x greater than or equal to 10, you know, just to get over that little hiccup at the start. And it's a little bit clearer to do that. So now that I know that is plus, won't our function be increasing then? Our sequence be increasing. Now, I want to find the limit as n tends to infinity of that guy. I would not make this a heavy duty question. This to me is simply brute force. Let's just make n infinite. Would you agree that 2 times infinity plus 3 over infinity is still infinitely large? Isn't 3 over infinity just going to be almost 0 and 2 infinities is going to be really big? And that makes it unbounded, right? If it has a limit, right, it's bounded. And if it has a limit, by that I mean it's a number, right? 0 or 2 or 3/4 or whatever, -1/2. As long as it has a value, it is bounded. If the limit doesn't exist, or if the limit is infinite, as it is in this case, it's unbounded. And that's how you answer that piece of the puzzle. We feel comfortable about that kind of homework question where they ask you those 2 things.
So what would be an example of an unbounded, or not, or of a Not monotonic.
And not monotonic. How about this fella? Now, I probably could come up with a better example than I will, but I want to show you this one just to show you that you don't always do the derivative check. If I did this one, would you agree that the answer goes, or the sequence, oops, the sequence looks like this. When you plug in 1, you get -1 plus a half, -1/3 plus 1/4. In this particular case, couldn't we just use logic to say this sequence clearly alternates between positive and negative numbers for eternity? Even although those numbers may be getting smaller, it's never decreasing, then decreasing, then decreasing, right? Isn't it going down and then up a little bit, but then down a little bit more, and then up a little bit more, right? All the way for infinity. Another one would be, say, that function there. If you differentiated that function, you'd get the cosine. Isn't the cosine sometimes positive and sometimes negative? In fact, doesn't it basically go up and down forever? So can you imagine that a sequence that used that would be non-monotonic as well? Does that help?
Yes, thank you.
Right. Not every single sequence is going to be done algebraically. Some sequences you just have to use, for want of a better word, mathematical common sense, right? It's kind of obvious that that sequence is not decreasing all the time. I think actually, I would probably say in both these questions, isn't it kind of obvious that the sequence goes down and up depending on the n value, right?
Mm-hmm.
And there's no pattern to it. Is this sequence bounded? That's a different question. It is, isn't it? What's the biggest number the sine can ever be?
1.
A -1. So this is bounded. Now, I didn't do limits and I didn't do algebra or anything else. Didn't I just use mathematical knowledge or common sense that I know what a sine function can do? Okay. Do you think this sequence, which is also non-monotonic, right? Do you think this one is bounded? And the answer is yes, it is. If you imagine the first answer was at -1, which is here. And then the next answer was at half, then -1/3. Isn't it a bit like damped oscillation? Isn't it bounded because none of them ever get lower than -1 and none of them ever get bigger than +1? Actually, none of them ever get bigger than a half, if you're being really nitpicky about it. And that's what bounded means. All the values of the sequence are bounded in like a little railway track, right? They're all inside it. Even although they don't decrease or increase, can't you ziggy-zag inside a boundary as well? And so both of these are bounded, but not monotonic, right? They're not increasing, they're not decreasing, they jump around, but nonetheless, they can be bounded. Can you be an increasing function and not be bounded? Can a function get bigger and bigger and bigger and not be bounded? Yeah.
Yeah.
Can you just be the sequence 1, 2, 3, 4? Doesn't that increase all the time, but doesn't it also shoot off to infinity? It's not bounded. Any questions? We're good? So if I gave you a sequence and I asked you, is it increasing, decreasing, or not monotonic? You understand what you need to do to find that? Sometimes you'll use calculus, sometimes you'll use mathematical common sense. And then the second question very often is it bounded or not bounded? And You can use limits, or you can use mathematical common sense. Let's do another one that involves mathematics instead, calculus. Here's an interesting formula for a sequence. And I would like to know, is it increasing, decreasing, or not monotonic? So that's the first part. And in this case, I will do the algebra. Would you agree this is a product rule? And I'll make this F, I'll make this piece G. So the derivative F dash G plus F of G dashed. And that gets me 2x, leave that guy alone, plus x squared. If you differentiate e to the negative x, you do get e to the negative x. But what else do you get? Times, correct, -1. So you put this together and pull out, I know, e to the negative x and an x as a common factor. You're left with 2 take away x. And I want you to think of x, let's pick 10 just to be safe again, right? If x is any number bigger than or equal to 10, won't x be positive? What's e to the power of a number, like e to the negative 10, e to the negative 20, e to the negative 500? Is it positive or negative, all those examples?
Positive.
Positive. They're just very small, but they're positive. Now, 2 take away x, 2 take away 10, 2 take away 2 million, 2 take away 1 billion. Would you agree that as long as x is a big number like 10 or bigger, would you agree that that is negative? So what does this combination tell me? It tells me that the derivative is negative. So won't that make this one a decreasing sequence? Factoring it and then taking each factor separately and testing, is it positive or negative for values of x greater than or equal to 10? Doesn't that help you figure out what the derivative is? If you left it like this, wouldn't it be a bit of a guess? It could be negative, it could be positive, you can't really say for sure. If you factor it out, style points, it's a little bit clearer. Now, let's do the bounding. Is it bounded? And I am going to change how this fella looks. Why am I rewriting that guy in this form? I'm doing it for a reason. What's my reasoning?
L'Hopital's rule.
We want to use L'Hopital's rule. Yeah. And for L'Hopital rule, don't you need a fraction? And to remind you, because it may be a little bit since you've done it, put a little L above it to tell people that's L'Hopital's rule you're using. And according to L'Hopital, can't you just find the derivative of the top and the derivative of the bottom separately? And then the limit as n tends to infinity. Now, if the answer is still infinity over infinity, which it is in this case, don't you just do L'Hopital again? And so if I do L'Hopital one more time, that guy becomes 2, derivative of that, and now I can do brute force. Because isn't e to the power of infinity just infinity? And so 2 over infinity gets me 0. This has a limit. The limit is 0. And since it has a limit, it will be bounded. Right? Zero's a number, right? Just like 4 or 3/3, 3/4 is, right? Just a number. If the limit is a number, it is bounded. If it's not, right, if it's undefined or it's infinity, it's not bounded, right? You've got, it got to be one or the other, right? And that's how you decide. I see some nods there. Visual clues help me a lot. I like noise. So now we are going to look at limits of sequences, just limits. Now they use some terms here, so let me show you what that looks like. If you find the limit of a sequence and it's equal to a number, any number, right? So you find the limit and it's 0 or it's 42, then we will say that this sequence converges. And not only will we say it converges, we will say it converges to that number. So for instance, if I went and said to you, what about this guy? Could I just say, I could do it in my head, would you agree that this guy converges to 0? That would be the language we would choose. So we are going to look at finding the limit of a sequence. And if it's a number, it converges. And if it's not a number, if it's infinity, or it doesn't exist, we will say it diverges. Can you remember converges and diverges notation used in Calc 2? Right, if the area under the curve was a number, we said it converged to 2. If the area under the curve was undefined, didn't exist or was infinite, we said it diverges. Same language. So if a limit exists, it's bounded. If a limit exists, it converges to whatever that number is, right? So it's not a different concept, right? Bounded and converges, unbounded and diverges, almost the same thing. What's the difference going to be? Well, we're now going to look at one-off situations. We're going to look at how do you find limits where L'Hopital doesn't work, right? Or where the divide top and bottom by n doesn't work, or just brute force doesn't work. And so in those questions, you've got to be a little bit more creative. So here's my first example. And I'm going to try and find the limit. And here is, there are lots of different strategies. So this is just one of the strategies that works for this particular situation. And you only get like a couple of shots of any of them. So it's not like you're going to have a lot of practice at these. But here's one of the strategies. When n is really, really big, isn't 1 plus 2 to the n darn close to behaving the same way as 2 to the n? Would you agree that 1 plus 2 to the power of a million and 2 to the power of a million are negligibly different, right? There's, for all intents and purposes, they're just as big. And the bottom is this guy. Now that makes this fella him. So this limit is approximately the same as finding this limit. Now, if you take a number that is less than 1 and you raise it to a really, really, really large power, what answer do you typically get?
0.
Say that again?
0, it gets infinitely small.
Yeah, you get 0. How about this one? Well, it behaves like that. And the limit as n tends to infinity of the original behaves like that guy. What happens if you take a number that's bigger than 1 and raise it to the power of an infinitely large number? What do you get in this case? Like 2 to the power of infinity, that kind of thing. What would you get?
Infinity.
So what we have here in the top one is that this sequence converges to 0, and in this, it diverges. Now, that's the difference between the two in that case. Okay, so that's one of special situations. Let's look at this fella. Oh, a new notation. Sometimes you'll see a sequence written like this. It's the equivalent of someone just telling you that. That's all that notation means. Instead of saying AN equals that, you put little curly brackets and you stick the formula inside. Right? So you're going to see a couple of sequences where they use this notation rather than that. Me personally, I like that notation. That one is a little bit distracting in my brain. But it means the exact same thing, right? These are totally equivalent, right? They're saying the same thing. Now, I am interested in finding what the limit of that is. Suggestions of how I might approach the question. Because there are two ways to do this. Both work.
L'Hopital's rule?
That's version number 1. If you differentiate the natural log of 3n, won't you get 1 over 3n times 3? And if you do the 7n, you get 1 over 7n times 7, which means you get 1 over n over 1 over n. Well, by the way, isn't that just 1? So the answer is the limit is 1. Or, as I said, there are two ways to do this question. Can you split the log of 3n as a log of 3 plus the log of n and do the same with the log of 7n? I could do that. Couldn't I do L'Hopital on that and get 1? Or can I do some surgery? And say that for very large values of n, doesn't that fraction really look like 1? It looks like ln on the top over ln in the bottom. So in this case, it converges. And it converges to 1. So when it converges, you stick a 1 inside the box. That's what your homework would look like as an answer. Or 0 if the answer was 0. Any questions? We're looking good. Right. I just have a very special function. Came out of the blue. I think there's only one question with it, but it's a pain in the butt, so let's get it over with. Can you remember factorials? A few nodes, a few what the hex, right? 7 factorial is basically 1 times 2 times 3 times 4. I wish I hadn't picked such a big number, all the way up to 7. And I'm going to do a sequence with some factorials in it. This, in fact, is question 12. Or it's my question 12. And I can't do L'Hopital, I can't do brute force. I got to figure out how to deal with this. So this is how I'm going to approach this question. What would 8n minus 1 factorial look like if you wrote it out in full? Well, it would be 1 times 2 times 3 times, and you would finish at 8n minus 1, agreed? And those dots in the middle just represent all the other terms that would get you from 3 to that value. Now, if you did 8n plus 1, you'd get 1 times 2 times 3 times. Eventually, you'd get to there. And this is where the sneaky part happens. What would be the term before 8n plus 1? What would that guy be? Oh,
8n.
Yeah, 1 less, 8n. And what would the one that would come just before the 8n, what would it be?
8n minus 1.
Now, when you look at the 2 factorials written out in full, can you see some carnage? Can you see an awful lot of things cancelling out with an awful lot of other things? In fact, isn't there a 1-for-1 cancel? And what's left is a 1 on the top and an 8n and an 8n plus 1 in the bottom. In other words, doesn't this sequence, isn't it the same thing as that fraction? But that's dead easy to find a limit of. Can't you do that in your head and the answer is 0? And so it converges to 0. Now, do you see in that case, I didn't do L'Hopital, and I didn't even do the, it behaves kind of like this, you know, where, you ignore most of the terms and only keep the big ones. So you're going to have to be aware of how to deal with a factorial or something unusual, because they're going to keep chucking some things that I haven't thought of, and you're going to have to figure a way of telling what the limit of the sequence would be if it exists. So here's another one which is like 15. And what I'm going to do here is do some algebra. I'm going to try and make this look different. And the version that I turn it into is going to help me figure out a better or simpler way of getting the limit as n tends to infinity.
Is that natural log or 1n?
It's a natural log.
Thank you.
What's the rule for combining 2 logs that are subtracted?
Divide.
Now, I am going to find the limit as n tends to infinity of this guy. there's a little trick I can do here. Do you know if you want to find the limit of a natural log of a fraction, can't you find the natural log of the limit of the fraction? And it's the same thing. You can switch places. That you should be able to do in your head. What's the limit of 2n plus 1 over 2n? Do a little baby L'Hopital if you want.
One.
But what's it? It's 1. So this is going to be the natural log of 1. And what's the natural log of 1?
0.
A big 0. So this guy converges to 0. So can you see you're going to have challenges here of every question's going to be kind of unique. You got to figure out an approach for every situation, right? And each one's going to be, oh, that's not quite like the last one. So here's another one. This one is kind of like 16. And there are a couple of ways that there's at least 2 ways I can approach this question. Anybody get any suggestion? Maybe you'll figure a third way that I didn't think of. I want to find out what the limit of this is as n goes infinite. So last question for today. I'm not going to tell you. We'll do it tomorrow. I'll give you a chance to think about it. Will you all say hi? And we'll get the attendance thing done. And I'll see you all tomorrow. I'll hang about for 5 minutes if anybody has any questions. Except, how do you do that one? Because I'm not going to answer till tomorrow.
Thank you.
Have a good day. Thank you.
You